Hey guys, welcome back. Houston Math Prep here. In this video, we're going to continue looking at probabilities for binomial experiments. So, according to a recent report, 11% of Americans live below the poverty level. Suppose you plan to sample at random 100 Americans and count the number of people who live below the poverty level. What is the probability that you count exactly 10 in poverty? So this is a binomial experiment with n, or our number of trials, being how many we're going to ask, 100. The number of successes that we're interested in here is exactly 10. Our probability of success is 0.11, or 11%. And our probability of failure would be 1 minus 0.11, or 0.89. So if you were using your formula, probability of x equals 10 would be 100 choose 10 times 0.11 raised to the number of successes, which would be 10, times 0.89 raised to the number of failures. If I have 100 and I have 10 successes, then I would have 90 failures. If you were using your calculator, then that would be binomial PDF with your number of trials, 100, comma, your probability of success, 0.11, comma, your number of successes interesting, 10. Either way, you should get 0.1251, and that's rounded to the 4th decimal place. So the probability that you count exactly 10 in poverty is 0.1251. So let's look at a question very similar but asked a little bit differently. In this case, what is the probability that you count 5 or fewer in poverty? So 5 or fewer, what does that mean? Well, that would mean 0 in poverty, 1 in poverty, 2 in poverty, 3, 4, or 5. So it is all of those outcomes combined. So if we were to do this, we would have to find the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2, and so on up through the probability that x equals 5. Now that's only 6 probabilities to find and add together, but already that's seeming a little overwhelming. Imagine if I asked, what is the probability that you count 80 or fewer? Well, that would just take forever, so surely there has to be a better way, and of course there is. And that is by using something called the cumulative binomial distribution. So the cumulative binomial distribution helps us calculate the probability that x is less than or equal to a particular number of successes. So if you were to think about, kind of a number line, right? And here is your little x, your number of successes. It's going to help you count how many are below that. So our binomial cumulative distribution function, or CDF, is once again underneath that distribution menu, just underneath the binomial PDF. So CDF is for cumulative distribution function. When you bring it up, it asks you for the same information, your number of trials, n, your probability of success, p, and your number of successes that you want to be less than or equal to. If you have an older version of the calculator, or if this screen does not come up, you're going to input your information in the same order that you did for binomial PDF. N, then P, then X. So let's look back at that same example, that same question, and let's use binomial binomial CDF to answer it. So our number of trials is 100, our probability of success is 0.11, and we want x to be less than or equal to 5 because we have 5 or fewer. So our probability that x is less than or equal to 5 can be found using binomial CDF with 100 as our number of trials, 0.11 as our probability of success, and 5 as the number we plan to be less than or equal to. And putting that in and hitting enter, we get 0.0302, again rounded to 4 decimal places. So much faster and more efficient than finding 0, 1, 2, 3, 4, 5 and adding them all up. Okay, let's try one more. What is the probability that you count fewer than 25 in poverty? Notice here a slight difference in wording. Fewer than 25 versus 5 or fewer. 5 or fewer includes the number 5. Fewer than 25 does not include 25. So that is going to translate to x is less than or equal to 24. Because if we're thinking about a discrete probability distribution here, we can have 0, 1, 2, 3, all the way up to 24, and those are all the things that are fewer than 25. So with the same n is 100, the same p is 0.11, and now x is less than or equal to 24, our probability of finding fewer than 25, which is x is less than or equal to 24, is our binomial CDF, or cumulative distribution function, 100.1124. Putting that in and hitting enter, we get 0.9999. So almost 1, right? Almost. And that is our probability of counting fewer than 25 in poverty. All right, guys, that does it for this video on binomial experiment probabilities. We'll catch you in the next one.